In calculus, a lot of times we want to look for what are known as the absolute extrema on an interval. We have two basic steps to finding absolute extrema on a closed interval. The first step is we need to find all the critical values of f, which is f of x, on the given interval. The second step, we need to plug the critical numbers and the endpoints of the interval into the original equation to find the y values, and whatever is our biggest y value is our absolute max, whatever is the smallest y value is our absolute min. Now, a couple things here. First of all, if you do not recall how to find critical values of f on the given interval, go back and watch my other YouTube video called Critical Values, parentheses, Critical Numbers. The other thing is, it tells us that we're going to take those critical numbers and the endpoints of the interval to plug it in and find all the y values of every single possibility here. That's because I could have a graph that looks something like this. Let's say it started up high, and then it came back down, went up, and then came down after that. Well, in that case, normally in algebra we call this the minimum point and this the maximum point. However, the absolute extrema comes from the highest y value or the lowest y value. So my absolute max would be the biggest y value on this interval, which happens to be up at the top. The absolute min is the smallest y value, so the point where we have the smallest y value is down at this endpoint down here. What is normally this maximum point is just a maximum in between, and so that is what we call a relative max. And then this minimum point right here is just a minimum point in that local area, so that is called a relative minimum. That is why you have to check both the critical values and the endpoints, because the critical values will give you this relative min and this relative max, but in this case, the endpoints are what form the absolute max and the absolute min. So here's our first example. It says find the absolute extrema for f of x is equal to 3x to the fourth minus 4x cubed on the closed interval -1 to 2. This closed interval right here is x equals -1 to x equals 2, so those are x values. So based on the previous steps we saw, first step is differentiate. Now this is a nice easy derivative, so f prime of x goes to 12x cubed minus 12x squared. Critical numbers are where we have the x coordinates where the derivative is either equal to 0 or does not exist. In this case, this could only equal 0. It cannot be undefined. And then I can factor out a 12x squared, leaving me with x minus 1. So I end up with x is equal to 0 and positive 1. Those are my critical numbers, or like I said, critical values. Same thing. So what I want to do next is I want to go ahead and make a list of points here. And my points need to include the critical values and my endpoints on this interval -1 and 2. Now, of course, you have to make sure 0 and 1 are between those two values, and in this case, they are. So making a list of xy coordinate points where I have the critical numbers plugged in and also the endpoints plugged in. And then what I'm going to do is I'm going to take each of these x values, plug them back into the original f of x to get the y's, and that's what I'm going to list right here. And then I'm just going to compare to see which is the biggest, which is the smallest. Well, if I take 0 and plug that into f of x, I end up with 0 minus 0 is 0. If I take 1 and plug that into f of x, I end up with -1. If I take this x equals -1 and replace that with x in the original function, I end up with the y value of 7, and 2 will go to 16. So the lowest y value, my smallest y value, is what we call the absolute minimum point. That would be at that 1, -1. And I'm going to abbreviate, that's my absolute min. The highest y value is where I have the absolute maximum. So that's at the 2, 16. So that's my absolute max. And those would be my answers. Now, those other 2 points that we have listed, the 0, 0 and the -1, 7, we're not going to look at what those mean today. They could possibly mean something later on, but at this point we're just going to ignore them. They just are extra points that came from either the critical values or the endpoints. So let's look at another one. This one says, find the absolute extrema for f of x is equal to x cubed minus 9x squared plus 15x on the closed interval 0 to 3. So again, start by differentiating. f prime goes to 3x squared minus 18x plus 15. That cannot be undefined. It can only be equal to 0 for the critical values. And I can factor out a 3, leaving me with x squared minus 6x plus 5 equals 0. That does factor further, so I have x minus 1 times x minus 5 is equal to 0. So my critical numbers turn into 1 and 5. Now, here's where you have to be careful. We are only solving between x equals 0 and x equals 3. So 1 is between 0 and 3, but 5 is not. So that one I actually do not want to keep, so I'm just going to draw an x through it, because it's not a critical value that we're actually going to keep between 0 and 3. So then the next step is I need to take that critical number, as well as my two endpoints of 0 and 3, and I'm going to create a list of coordinate points by taking each of these x values, plug it into the original function. So if I take 1 and plug it in, I have 1 minus 9 plus 15 is going to give me 7. If I take 0 and plug it into f of x, I end up with 0. And if I take 3, cube it, minus 9 times 3 squared plus 15 times 3, that will give me negative 9. So my biggest y value is at 7, which means 1 comma 7 is my absolute max. And my smallest y value is down at negative 9, so 3 comma negative 9 is the location of the absolute minimum value. And those are the two answers I was looking for. That 0, 0 again is just another point. We're not going to worry about it right now. Okay, our last example. Find the absolute extrema for f of x is equal to 2x minus 3x to the 2/3 on negative 1 to 3. So again, start by differentiating. So f prime of x goes to 2 minus 2x to negative 1/3. Now, if you watch my video on critical values, you'll know that with a negative exponent, we have to rewrite that as a fraction. So I have 2 minus 2 over x to the 1/3. Combine those two together with a common denominator to make one fraction. So my common denominator is x to the 1/3, so I'm going to multiply this 2 by x to the 1/3 over x to the 1/3, which leaves me with 2x to the 1/3 minus 2 over x to the 1/3. Critical numbers come from where f prime of x, which is this derivative here, is either equal to 0 or does not exist. A fraction is equal to 0 when the top is equal to 0, and a fraction is undefined when the bottom is equal to 0. So I actually need to set both parts equal to 0. So if I do so, the top part gives me x is equal to 1. Bottom part gives me x equals 0. Those are my critical values. Both of the 0 and the 1 are between negative 1 and 3, so I'm going to keep those points. Let me just move this up a little bit. So now when I make my list of coordinate points, I have 1 and 0 for the critical values. My endpoints were negative 1 and 3. And then I just need to go back and plug it into the original function to find the y value. So if I take 1 and plug it into the original f of x, let me zoom out a little bit so you can see it better. So if I take 1 and plug it into the original, I have 2 minus 3 gives me negative 1. If I take 0 and plug it in, I get 0. And if I take negative 1 and plug it in, I'm going to end up with negative 5. Now, when I take 3 and plug it in, I end up with 3 to the 2/3. That is not an integer, so this is actually going to go to a decimal. And using my calculator, I found that it went to negative 0.24. So the biggest y value here is actually 0, so that's going to be my absolute max. And my smallest y value is negative 5, so that is my absolute min. And those are the 2 points I was looking for. Now, if one of these others had had the same y value as the 0 or the negative 5, you can have more than one absolute max or min as long as they both share the biggest y value or the smallest y value. So thank you very much for watching. If you don't mind, please subscribe, and I would really appreciate it. Thank you.